Hey everybody, we're going to try this lesson 5 entrance question together. I'd like you to hit pause, try the question, and then come back like we have been doing. So let's start off here with question 1. Go ahead and hit pause and then come back when you are ready to see the answer. So in number 1, we're looking at this equation, and what I'm noticing in the equation is it seems like there's not a lot of information there. But they do give us the A value, and they do give us the D value. Now that's a lot of information. If I start off with my D value, which is the midline, it tells me that -3 is right at the middle of the graph. And I use my amplitude to find the max. So if I was to go up 2 units, that would take me to the top of the graph or to the maximum point, which would be -1. And if I go down 2 units, that would take me to the minimum point, which would be -5. So my median line written as equation, y equals -3, maximum point, -1. The range would be 4 units. So talking about how far it is from the bottom to the top. Another way of doing range is with set builder notation. The range is y, such that -5 is less than or equal to y, which is less than or equal to -1. And y is an element of real numbers. Amplitude is our A value, so amplitude is 2, and the minimum would be -5. Okay, hit pause and give number 2 a try. So for number 2, the graph of a function goes from quadrant 3 to quadrant 4 and has 1 turn. So let's see what we're dealing with here. So quadrant 1, 2, 3, 4. So in order to go from quadrant 3 to quadrant 4, it would look something like this. It could be, let's see, only 1 turn. I was going to say that any even degree would go from quadrant 3 to quadrant 4. But to have 1 turn means that it would be a second degree. The degree is always 1 more than the number of turns. And since it's opening down, so for a quadratic, we say that that's like a negative slant to it. So we say it has a negative lead coefficient. All right, give number 3 a try and then come on back. So here we're looking at which of the following rows includes 2 functions that have similar end behavior. So things to keep in mind here. When we're looking at end behavior, what we know is that anything with an even degree will have a similar end behavior. So if it's a second degree, it's going to have 1 turn. A 4th degree, similar end behavior, still going from 3 to 4, but more turns in it. But they do have a similar end behavior. We could say the same thing for anything that has an odd degree. So if we were looking at, let's say, a 1st degree, a linear graph, compared to a cubic, same end behavior, just a different number of turns. So for this one, we should say D. Here we've got a degree of 1 and degree of 3. So there we've got the odd degrees. They both have a positive lead coefficient. So I know that they would both have a similar end behavior to what I have in my sketch over here. All right, I hope that made sense. And keep working at it, guys. We'll go next into lesson 5.